Hey there, awesome physics students. Let's talk about series circuits and how current and voltage behave in those circuits. Before we explore the circuits aspect, I want to talk about a physical situation inside of a building. There's 5 floors in the building, and you start out in the basement level, so that's like the 0th floor, and you're basically in the basement, and you get into an elevator, and the elevator travels up to the 5th floor. And so by doing this, traveling in this elevator, you yourself have increased your potential energy as you go from the 0th floor to the 5th floor. You've increased your potential energy. Then you get out and you walk along the floor, the 5th floor, on a level floor. And by walking along that level floor, your potential energy does not increase or decrease. Your gravitational potential energy stays constant. Then you come to a structure and there's this big open lobby, and you actually travel down several flights of stairs. So you come down the stairs, and so this is a difference of, so you go from the 5th floor down to the 2nd floor. So you're going down 3 flights of stairs here, but it's just one long staircase. And then finally you travel along the floor again, level. Your gravitational potential energy doesn't change, even though it just decreased a little bit here. It doesn't change again, and then you travel down some stairs and you decrease your potential energy back down to the 0th floor, and you can travel back into the elevator if you wish. Okay, I'm going to draw the analogous circuit to this. So what is the device that increases a charge? You're the charge. What is the device that increases a charge's potential energy? Well, that's a battery, right? And so here we've increased it from 0 to 5 floors. So I'm going to go from 0 volts up to 5 volts. Okay. Now, at this point, I didn't change my gravitational potential energy. So in doing that, I'm just traveling along a wire. As the charges travel along a wire, their potential energy or their voltage does not change. Then finally they reach some kind of device that's going to decrease their gravitational potential energy, or their electric potential energy in this case. And that's a resistor. And so they travel down that resistor, and as the particles, the charges, travel through the resistor, their potential energy decreases. And so here they're on the 5th floor, or they're at 5 volts, and then how many volts are they here? Well, we went from the 5th floor to the 2nd floor. The voltage drop is 3 floors, so we're going to drop 3 volts. The voltage drop across this is 3 volts, so now we're at 2 volts here. Okay. Then we travel along another wire. Our electric potential energy does not change, traveling along this flat surface. And then we go down another set of stairs. This is another resistor. And our voltage then decreases from 2 down to 0 volts. And then we can travel along a level surface again. Our potential energy doesn't change as we travel along the wire. And we go back into the elevator, and we can do it again. Okay, so this is resistor 1 and this is resistor 2. Now, a few things to note here. If 5 people get into the elevator, that's 5 charges. They all get out of the elevator. So all 5 charges, that's your current here, that's 5 amps, that will come through, and all of those charges will all have to go down this staircase together. If 5 charges enter the staircase, 5 charges will come out at the bottom. Likewise, if 5 amps comes into this resistor, 5 amps has to come out at the bottom here. That means 5 amps then has to go into this next resistor. 5 amps has to come into this staircase here, or 5 people. Right? And then 5 people come back down at the end. That means 5 amps comes out of the bottom resistor, and then all of those charges go back into the battery there. Notice that the voltage drop across these elements is not the same, but the total voltage drop that is 3 plus 2, will equal the voltage of the battery here, right? The voltage of the battery here is 5. Here the voltage drop is 3 volts, and here the voltage drop is 2 volts. 3 plus 2 is 5 volts, okay? So in a series circuit, the voltage drops add to the total, whereas the current must be the same through each device. Or in other words, the gravitational potential energy, the total decrease in gravitational potential energy must be equal to the increase in the elevator. That's the voltage. And the number of people coming out of the elevator must be equal to the number of people coming into the elevator. That's the current. And the number of people going down each staircase must be the same. Same number that come down the first staircase also go through the second staircase. Okay? Hopefully this helps you understand series circuits a bit better with voltage and current.